Hi there, I'm John Lebensold for Killer PHP, and today what I'm going to be talking about is left joins and right joins, or they're also known as inner joins and outer joins. And we're going to be building off of an example from the first video where we created a category table and a post table. So I'm just going to go back to my wonderful script that was written in the last video. And here you can see that we've basically got code to create a category table, and we've got code to create a post table. And then we've just got a bunch of insertions into the category table and then a bunch of insertions into the post table. So far, so good. So if I just select all of this and I paste it in, then I should be able to do a very simple join by doing something like select star from post p left join category c on p dot category id equals c dot id, which was the last thing we did in the last video. So if I hit enter, as I mentioned before, you're going to get an ID and you're going to get a category ID and so on and so forth. Now, this isn't exactly the best way of doing a select statement, because you'll notice that now we've got these two ID fields, which can be very misleading. If you were to run this query in PHP and then you wanted to grab everything from the ID field, PHP might actually get confused as to which ID column you're talking about, since we've got one ID column on the left, which is going from 1 to 6, and the other one on the right, which is basically the join on categories. So one way of mitigating that is to actually be a little more specific in our joins. We can do something like select p.title, comma, p.content, comma, c.name from post p left join category c on p.category underscore id. So you'll notice that this is exactly the same thing that we just did, except that now, instead of this star, we're actually replacing that by being a little more selective about the columns that we're asking for. The only part of this select query that's changed is the star. The star has been replaced by title, content, and category name. And so now I'm getting something a little different. Oh, whoops, I forgot the on category underscore ID is equal to c.id. There we go. Sorry about that. So here, now I'm getting something that looks a little more useful to my PHP application. The advantage of something like this is that, let's say I want to change politics and I want it to be uppercase now. I only need to make a change to one table and one place. So if I do an update statement and I say update category set name equals politics, where name equals politics, and then I were to rerun this query, then you'd notice that both of these categories automatically changed. And that's really the power of a relational database, is that you can change the way that the database is relating information and making sure that at the same time you only have one copy of every single bit of data. And by ensuring that you only have one copy, you're going to make sure that there's a high level of integrity to your data. If somebody changes something, then everything else is going to change. As opposed to, if you had an employees table and you had, if you had like an employee with an HR department, and then you had a project manager who also had their own, listing of the employee, and one person decided to change the salary of that person and the other person didn't get wind of it, then you would have the scenario where you'd have the same data, but it would actually be different in two different places. And relational databases mitigate those problems tremendously through building these kind of relationships through primary and foreign keys, which is what we're doing. So that is a left join. Let's go back to the first left join that we did, which was this one right here. Now we can also do a right join, which is actually the opposite. So if I do a select star from post P, because you might see this. The right join, or also known as the outer join, on category C on P dot category underscore ID equals C dot ID, then we're going to get something a little different in that now we're going to get null values. And the reason is that we're joining the category table to the post table. And we end up with something like this, where we've got all the categories, including the categories that aren't even being used. If we wanted to take this a step further, and we were absolutely adamant about doing a right join, then we would want to filter that out. And we could do that just by saying where p.id, in other words, where the post ID is not null. And this would, of course, clean it up. Now, I want to illustrate one more kind of caveat in all of this. What if we have a post that doesn't have a category? It's a good question. So in my script over here, I'm going to just do that and see what happens. So I'm going to create another post here, and the title of this post is going to be, I don't know, favorite sandwich recipes. And it doesn't really belong anywhere. Well, probably belongs in other, but just to illustrate my point, I'm going to set this to null. So we're not going to have a category ID. Select all, copy, paste, and we're good to go again. If I say select star from post, I'm going to see that I have my category IDs, and then I've got my favorite sandwich recipes that are unfortunately not going to be represented here. So I think it's a good time now to actually start remembering these join statements in my script. I'll go back to the one we just did. So select star from post P, left join category C on P dot category underscore ID equals C dot ID. See, it becomes like a second language. And I'm just going to paste this at the bottom here so we don't forget about it. So here what we're getting is the opposite problem, where we've got a category or we've got a post, but the post doesn't have a category. Now, depending on the kind of business rules that you have, this might or might not be a problem. And this is really the flexibility that the database offers you. You know, if it's not relevant to a particular post, then you might just want to say where is not null for the category ID, much like what we did in the last video, in the last example with the right join. So that's a quick wrap up of left and right joins. Now, if I want to take this a step further, I want to talk about constraints. And to show you what I mean by constraints, I'm going to create a new post record, except this one is not going to fit our typical mold. We're going to have a title of a post called poorly selected category ID. And it's going to have a post ID or a category ID of 14. I'm going to select all, and I'm just going to paste it in. So now we have a different problem where I just did a join, and my join had a category ID of 14, but then my database didn't actually know what to join it with. And this is a very common problem when you're dealing with relationships if you don't add constraints. And a constraint basically means that you're telling the database, wait a minute, I don't want you to let me put in any number into my category ID table anymore, or my category ID field anymore. I want you to force me to make sure that that record exists somewhere. And doing a foreign key constraint, or a constraint at all, is actually not that difficult in MySQL. You'll notice, however, that once you do have anomalies in your database, like the one that we have right now, if I try and alter my table, if I try and alter table post by adding a foreign key constraint on the category ID, which references the category's ID field, which is what I want to do here. Basically, I'm saying, hey, there's a relationship between category ID in my post table and the ID in the category table, if I try and do this, it's going to get really mad at me, and it's going to say, no, 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 cannot add up or update a child row, and it's going to say that the foreign key constraint fails. So we need to solve all of these data integrity issues before we start introducing foreign key constraints. I mean, in our case right now, it's really easy, right? We just have to go and we say update, set, update post, set category ID equals null, where category ID equals 14. And then if I try and re-alter the table, everything is going to be fine. Now if I go back and I try and take something where, let's say, the category, if the ID is 8, which in this case it is for poorly selected category ID, and if I try and set the category ID to 14 now, it's actually going to protect me. This is a protection. I mean, this is basically saying, look, I can't do a join on an ID that doesn't exist. So now if I go back to my left join, at least I'm not going to get a weird anomaly where my category ID is one thing and then the actual category table doesn't actually have that content anymore. Which leads us to another problem, and that's cascading. So when we do set up a foreign key constraint, there's another part of this, which is what do we do when something is deleted in one of the tables and the other table is dependent upon it? So like, for example, if I have two postings in my post table that are related to the politics column, then if I delete the politics category, what do? Do we delete the two political postings, or do we just set the category ID to null? And this is a really interesting problem as well, and luckily MySQL can actually fix and solve this problem too. So in my alter table post add foreign key category ID references category ID, I can actually specify what happens in the event of a deletion. So I can say on delete, and the default is no action, but I can also, for example, have it delete a record. So I can say on delete cascade. And what this will do is it'll basically cascade the deletions down to any relevant tables that are dependent upon the category. So now if I say delete from category where name equals politics, and it'll delete one row there. But now if I try and do my join here, you'll notice that it's also deleted my political postings, which is actually exactly what we want. And if I say select star from post, then they're actually gone now. So this is an example of on delete cascading, but we can also say on delete no action, which is the default behavior, I believe. So if I say on delete no action, actually, let's start back at the top here. So we've got our beautiful database, and I'm going to set this to null. Hit save. So we've pasted this all in, and then I'm going to alter my table post by adding a foreign key for category ID, which references category ID, and on delete no action. And it's saying that I can't do that for some reason. Alter table post, add foreign key category ID, references category ID, on delete no action. And it says that the constraint fails. Let's just see why. 1, 2, 3, 4, 5. That looks fine. Select star from category. 1, 2, we're missing the first column, which is the category. If I try and drop the table category, it's actually going to have to be dropped first before I can drop the table post, and that's what happened. So my script failed. So now if I run it again, and I do select star from category, I'll have 1, 2, 3, 4, 5, 6. Select star from post, and that looks okay. And now let's try altering our table with the foreign key constraint. Okay, good. So we can do that, and then I can add on delete no action. Hit enter. Perfect. Everything seems to be working. Now, if I decide again I want to delete from category where name equals politics, who needs them, then it's going to say, you can't do it anymore. Because if you delete politics, then it's basically going to create an inconsistency or an anomaly in your database, which is actually exactly what we want. So this is just an example of some of the ways that you can deal with constraints and how constraints can actually help you make sure that your database is responding properly. Another way of handling this is actually to set things to null. So instead of on delete no action, you could do on delete set null. And then if I try and delete the category with the name of politics, it's going to let me this time, except that if I do a select star from post again, I'm now going to get the null category IDs, which is very important. So I hope this was helpful. In the next video, we're going to start looking at one-to-many a little more in depth, and we're also going to modify our little table script to include an authors table and also to include the foreign keys right off the bat. I'm John Lebensold, and thanks for listening.